Question 7. A company makes and boxes spaghetti. One machine fills each box with approximately 32 ounces of spaghetti. After the boxes are filled, another machine weighs each box. A box is discarded if the weight of the box differs by more than 0.25 ounce from the target weight of 32 ounces. So differs. That's an important feature here. Which inequality can be used to find the range of acceptable weights X of the spaghetti? Well, first of all, differs means it could go above and below. So when you're talking about this question, think about 32 ounces. That's in the middle. But you can go as much as 32.25, right? If I add 0.25. But you can also go underneath. So you could, if you have $32, take away 25 cents, you're at 31.75 if I subtract 0.25. So we got some wiggle room. Not a lot, but there's a little bit of wiggle room here. And one of these absolute value inequalities is going to give you the answer. Now, one thing that actually is always going to be the case on these, it's always going to be a less than or equal to, because what it comes down to is these tolerance type problems. What we're trying to find is the difference from the actual weight from the ideal weight. This 32 would be the ideal, right? We want it to be 32 ounces, but it could be a little bit less and a little bit more. So you always want your ideal to be right there. But that is not the minus has to be there because it's the difference between the actual and the ideal. So there's going to be a difference there. And that difference can be no more than 0.25 ounces in either direction. So it's going to be C. And here's how you can do it on the graph on Desmos. You can type in the inequality so I can show you what's going on. To get the absolute value, you can hit the keyboard, click on the little vertical bar with the A, or you can hold down Shift, look above Enter, and see that vertical line. You could type that. But if I do X minus 32, first of all, the absolute value of X is a V-shaped, centered at the origin. If I do minus 32, it's going to shift it all the way 32 units to the right, because remember, minus makes it go to the right. So that's the graph. But now a funny thing happens if I do a less than or equal to, so I can hit this less than or equal to, and I put 0.25, I actually get a shaded boundary. And what happens is it looks like, if you zoom in a little bit, anywhere between 31.75 and 32.25 are acceptable weights according to this shaded boundary. So that's basically what I did on the number line here. 31.75 to 32.25 are acceptable weights. That's represented with this inequality. So it's always going to be your actual minus your ideal. That's going to be less than or equal to your difference. Pretty cool, huh? I think so.